Okay, here we have practice problem 2. I have a confession to make. I did this problem, and then I checked and I did not have the right answer. And I panicked, and I deleted it. And I was so close, I just did not follow the last step. I'm sharing this, A, so that hopefully you don't do it, and B, so that I don't do it again. And I will share with you what I did wrong also, or what I did not finish, I guess, if you will. Okay, so on this one, we are looking at a solution that contains 10 milligrams per 100 milliliters of potassium ions. And we want to express this concentration in terms of milliequivalents per liter. And here is where I failed. I did it as far as milliequivalents, and that didn't help. So I need to remember that I am specifically looking for milliequivalents per liter. And also, this is just a reminder of the formula. Milliequivalents is equal to weight in milligrams divided by the molecular weight times the valence. And now, if we wanted to do the concentration, literally that's just going to be adding in a couple of concentrations here into this equation. Should be easy breezy. I didn't do that in my last problem. I need to remember in exam that I need to add concentrations, if that's what it's asking for, and to answer what it's asking for, not what I think it wants. Okay, so what else do I know? I know that the solution contains 10 milligrams per 100 milliliters of potassium. We are looking for milliequivalents. Here is where I first made my mistake last time, because I was so excited to see milliequivalents and to write down my valences that I forgot that it was per liter. Anyhow, the valences, just because I need to remember my valences, I write this down every time. NH4, potassium, sodium, and chloride are all equal to a valence of 1, whereas calcium and magnesium have a valence of 2. Again, these ones will be found on your first column on the periodic table, and these ones will be found on your second column on the periodic table if you need help remembering that. And then now we plug and play. I am looking for the milliequivalents per liter, and that is easy because I'm looking for that over here. And I'm going to go ahead and I'm just going to call that S because I like S. It's pretty. Okay, so S is equal to, plug and play, my weight, but I'm actually looking for my concentration at this point. And again, to make it easy, it's going to be 10 milligrams per 100 milliliters times the molecular weight is 39. And that is 39 grams per mole. Grams per mole. And now I need to times it by the valence. So the valence is going to be 1 because this is potassium. And now I need to get my units to be correct here. And I know that I am looking for milliequivalents per liter. And I see milliliters here. I got to get rid of those milliliters and make that per liter. So that is going to be 1,000 milliliters per liter. And guys, I know it's easy to just say or to cancel out zeros and whatnot and go for it. Would suggest in an exam situation where it's high stakes, you write everything down and you just do it all. I don't know about you, but that's one of the problems that I often have is, I can get it right 29 out of 30 times, but it's that 30 time that's going to be on the exam when I get cocky and I know I can do it without writing it down, but then something happens. So on an exam, I will always write it down. And then I'm going to multiply 1 gram, divide, there are 1,000 milligrams per 1 gram. So that's going to get rid of my milligrams. I've gotten rid of my milliliters, and you can probably hear there's a dog fight in the background. So fun. Okay, moles. That's not going to be helping me. I need millimoles because milli equivalence has, there is 1 milli equivalent per 1 millimole, not per mole. So I need to do 1 mole is equal to 1,000 millimoles. And I'm running out of room. Great thing about using a iPad, I can manipulate, move, or resize. Love it. If you ever want any tips on iPads, let me know. And if you ever have any tips on to share on iPads, let me know. I love working with them. Okay, so those cross out. And then just to make sure everything crosses out and is happy skippy, I know that there is 1 millimole per 1 MEQ here. Okay, and then my millimoles are going to cancel out, and now I should find the correct answer. And so I'm going to have 10 divided by 100. And again, if it is on my numerator side, I'm going to multiply. If it's in the denominator area, I'm going to divide. So 10 divided by 100 is equal to that divided by 39. I'm not even going to hit equal to, I'm just going to do it. Multiply by 1,000, divide by 1,000, multiply by 1,000, and I should get an answer. And I do believe that was right compared to what I saw earlier. So my problem earlier that I had, and of course this is going to be my units that are left are milli equivalents per liter. I actually did it and I see them there. The problem that I had earlier is I did not do this step right here, and it left with me with 0.00256, and that didn't work. I panicked and deleted the video. Also, in a high-stakes situation, I will always double check my math on my calculator at least one time, make sure I get the same answer twice. If I do, I should be good to go, and then I will move on. 10 divided by 100 divided by 39 multiplied by 1,000 divided by 1,000 multiplied by 1,000, and again I got 2.56. So I have some assurity that I'm on the right track there. Often when I redo this, I'll get different answers, and then I'll need to redo it at least 3 times, make sure I get the same answer, because I got clumsy fingers, I guess, and I often hit the wrong ones. Anyhow, that's just another test taking tip there. Okay, so that was it for practice problem 2. Any questions, let me know.